Explain it.
Trying to find out how to find the specific heat of metal.
Putting hot metal and putting metal in water and recording the temperature change.
Temperature change of the metal or temperature change of
the water.
So what is that going to give you?
It's going to give it, well, we know the specific heat of the water, the mass of the water, and the mass of the metal. And
How'd you find the mass of the water?
mass of the water is pre-measured in that beaker.
Isn't that a volumetric measurement? 200 milliliters?
Yes.
So it has a massive...
200 grams.
Oh, okay.
This water. And we're trying to find out, we already know the mass, specific heat, and change the temperature of the water. And we already know the mass of the metal and the change of temperature of the metal, and by looking at the equation, you're gonna find the specific heat of the metal.
Okay. How did you determine the temperature of the metal?
We determined it.
Yeah, how did
We haven't determined it yet.
She measured over there. It was 81 degrees.
Oh yeah. Oh yeah. It was over there.
Pre-measured.
So do we have...
How does it take to find out the heat absorbed by the cold H2O and the heat lost by the hot?
We fill in the formula.
Fill in the formula.
Eventually find out.
So if you guys can find out the heat absorbed by water, what does that tell you about the metal?
The metal it gives off.
Well, what are you hoping to find about the metal?
How much heat goes off? Or
The specific.
The specific heat?
The specific heat of different stuff.
So,
We know water
But
is
in this case, the
one.
metal. Yeah.
so how is it that you can say that the heat that your water soaks up is going to be equal the specific heat of metal? How do you jump from that to that?
we subtract it from the temperature of water.
Hey, what's the math?
Fill it in, put a variable in. If we know how much water is, and then we know them combined, we can find out what it's like solving for x, pretty much, isn't it?
Well, I'm just saying you're telling me that you're going to determine how much heat is absorbed by water.
Yeah.
And I'm asking you, how do you use that to determine the specific heat of metal? So you're saying you're equating the two, huh?
Yeah, we already know. We know how much it starts off as, and then we see the end product, and then we know how much the metal had to do with it, and how much it gave off.
Let me know how it goes. I idea what you're doing. So what are you guys trying to determine?
We're trying to prove that Q equals MC delta T.
No, we're trying to find
Trying to prove
what metals, the specific heat of metal. Yeah. That's what we're trying to find.
You're trying to determine the specific heat of metal, then why are you guys using water?
Because water, we know that specific heat of water, so if we take that and subtract it from whatever the specific heat of both of those are, we'll get the specific heat of metal.
And we could like set the equations equal to each other and find the specific heat of the metal and use nothing else.
So you refer to the equations equal to each other. What equation are you talking about?
Q equals MC delta T, and one of them, the equation says like the heat absorbed by the cold water, and then one is the heat lost by the hot metal.
Oh, that makes more sense. What do you guys anticipate, anything?
That the metal has a higher specific heat than water.
it's the same.
Everyone agree?
2.2.
Everybody agree?
Yes.
You're going to think it has a higher C than water. Okay. Let me know how it goes.
We're trying to find how much heat this metal slug lost by putting it in cold water.
So you're trying to find out how much heat that lost in cold water.
Yes.
What did you find out?
It started out at 81 degrees and it dropped down to 25.7.
That slug went from 80 to the 20s.
Well, the water that it was boiling in was 81 degrees.
So what's that going to help you determine? So you found how cold the metal got, but now what?
Now we have to plug it into this equation. Q equals MC delta T. What's Q? Q is... What's Q?
Q is heat energy, and that's measured in calories or joules. And then M is the mass of the mass of the substance.
And then we have to find C.
C is, well, for water, C is it's a specific heat. So in calories, it's 1 calorie over 1 calorie per gram. And then for when measured in joules, it's like 4.1. But
So you're telling me two different things I'm not quite understanding. You watched a metal cool, you watched water heat up, and you got this equation MC delta T. Which are you going to apply that equation to, the metal or the water?
Water.
well, we're gonna take the we're basically gonna take the energy. We're gonna connect the two. We're gonna take the energy from the gained by the cold water because we took the metal substance from the hot water and moved it to a source of cold water, and that in turn the cold water gained heat because of that hot substance moving into the cold water. So we're gonna have that equation of the cold water, the energy gained by the cold water, and then we're gonna set that equal to the energy lost by that metal that had to, when moving into the cold water, it lost the temperature from being cold.
So you set those both equal, and then what's your ultimate goal to find?
We have to find the final temperature of the object in the water.
You sure? Because he's talking about energy. You're talking about temperature.
Well, because the heat energy
Why do you need
gained.
MC delta T to find the final temperature? What's your ultimate goal?
The specific heat of the metal.
Oh, okay. Your turn. To do what?
Find the specific heat of the metal.
And can you do that using what Henry described?
I don't know.
You gave up and you're on to something good. All right. Have fun.